Bismillahirrahmanirrahim. So this is the statement 2 of Snell's law that we are going to study. Okay, this used to be in the previous version of physics book of SSC level. So when light ray obliquely enters from one transparent medium to another transparent medium, that is what should happen for refraction of light. Okay. Now, for a fixed color of light and fixed pair of media, this condition is very important to mention. Okay, that's why I would like to box it. For a fixed color of light, if you change the color, then the constant will change. The constant that we are going to talk about, that will change. Okay, and also the fixed pair of media. Let us say light ray is going from water to glass. So water is a medium, glass is a medium. So they are pair of media. Media is the plural of medium. Okay. So fixed pair of medium. This is the condition. If you keep the two medium fixed and you keep the color of the light that is passing fixed. If it is red, then red. Okay. If you keep these two fixed, if you do not change it, then we are going to see that the ratio of the sine of the angle of incidence, the ratio, right? Sine theta, we are already familiar with. So sine of the angle of incidence, that is I, and to the sine of the angle of refraction, to the sine of the angle of refraction, that is sine r. This is always going to remain constant. This will always remain constant. You may change the value of I, that will result in change the value of R, but they will change in such a way that the ratio always remains unchanged. Okay, you understand? So this is the law. Okay, so when light ray is passing obliquely from one transparent medium to another transparent medium for a fixed color of light and for a fixed pair of media, the ratio of the sine of the angle of incidence to the sine of the angle of refraction. Remember, here I'm mentioning this part very clearly because many times I see the students writing the ratio of angle of incidence. No, the ratio of sine of the angle of incidence, sine I. So students sometimes forget to write sine. Okay, so you may box it and put a star mark so that you remember it whenever you are revising it, that you have to focus on this one. So the ratio of the sine of the angle of incidence, sine of the angle of incidence to the sine of the angle of refraction always remains a constant. Okay, this is the second law. Understood?
Sir,
This constant will be named something. What it is named, we will see now. Okay. Actually, I made a mistake. Okay, no problem. You already have this written in your notebook, right? So here I will just write the heading. That constant is actually called refractive index. Refractive index. Refractive index. And to write the definition, let us say in question A, okay, 1A, for 1 mark you have been asked to define refractive index. So what is the definition you need to write? At first you need to write this second statement of this Snell's law. Okay, you need to write this whole statement. You will end up here remains constant, and then you have to write this constant is called refractive index. Did you understand what I said?
yes.
Okay. So in the definition of refractive index, you need to write the second statement of Snell's law that I just wrote here. Okay. So after writing it, you will just add this part, that this constant is called refractive index. Okay. So this constant is called refractive index. But refractive index, it is of a certain medium. Okay. So what I was saying, this constant is called refractive index. Refractive index is like the name of a person. যেমন একটা নাম একটা মানুষের হতে পারে, তাই না? ঠিক একইভাবে refractive index টাও একটা মিডিয়ামের হবে। Now, as soon as reflection of light is concerned, two medium is involved, right? Number one, from which the light ray is coming, and number two, in which the light ray is going. Okay, so refractive index of which medium? The second medium. I will write it now. Okay, please take a closer look. The constant is called refractive index of the second medium. Second medium with respect to the first medium. Okay, and what is the symbol? The symbol with which it is denoted is eta. Okay, this is eta, মানে আমি যদি এভাবে লিখি ITA মানে ইটা, উচ্চারণটা বুঝতে সুবিধা হওয়ার জন্য আমি এটা পাশে দিয়ে লিখে দিলাম। এটা আসলে যেটা হবে কি n এর মতো লিখে জাস্ট লেসটাকে একটু লম্বা করে দিতে হবে। Can you see me clearly? Because I can see there is some problem.
টিচার কি বলি সিম্বল এটা হলো আর কি রিফ্র্যাক্টিভ ইন্ডেক্সের সিম্বল, তাই তো?
রাইট, যেমন ভেলোসিটি কে আমরা v দিয়ে এক্সপ্রেস করি, অ্যাক্সেলারেশন কে a দিয়ে এক্সপ্রেস করি, লাইকওয়াইজ এটা। I think you are already familiar with that because we used to express efficiency with similar. Okay? So the same letter. Most probably it is a Greek letter or a Latin letter. I actually forgot. Most probably Greek. Okay, eta. So this eta represents the refractive index. Okay. Now,
sir, I have another doubt, sir. Sir, my doubt is if sir incident ray angle is increased, so refraction angle is also increased, no?
yes.
Okay, sir.
Okay. So refractive index. Now refractive index is written in this way. See, I will write it clearly. This is A eta B. Okay, A eta B. Now what does this mean? This means that light ray is going from A to B. That means A is a medium, B is another medium, and light ray is passing from A to B. So the medium from which the light ray is coming, it will be written before eta, and the medium in which the light ray is going now, that one will be written later. Now let us say the light ray is going from glass to water. From glass to water. And at first what we will write? We will write eta. Okay, eta is the refractive index. From where it is coming? Glass. So we will write G first, and it is going to water. So we will write W later. So this will tell you that the light ray is passing from glass to water. Now, according to the definition, this is the refractive index of glass of water, of glass or water. I wrote a little bit ago that it is the refractive index of the second medium with respect to the first medium.
Sir, water.
Sir, water.
Water, because water is the second medium here, because into water the light ray is going. Okay, so we can write what we can write about this. This is the refractive index of B with respect to, I have written it in the short form WRT, that means with respect to. Okay, can you hear me clearly?
Yes,
Sir.
but writing is
Because they're saying low system resources may affect your audio quality. Try closing some applications to improve performance. But I don't have any applications open. I don't know. Okay. So refractive index of B with respect to A. Okay. So this is refractive index of B with respect to A. I always used to remember in this way. I used to think in my or imagine that arrow in this way. So this arrow shows the light ray is going from A to B. Okay. No problem, you can just remember it however you want to. Okay, now this refractive index is equal to, we got to know that sine I divided by sine R. Okay, Okay, now we will take a look at the absolute refractive index. Okay, we got to know what is refractive index. Now we will try to know what is absolute refractive index. Absolute. I will write absolute here. Okay. While I'm writing, let
Sir,
us.
there you write sign.
Okay. So let us continue. Absolute refractive index. When light ray enters into a transparent medium, whenever light ray enters into a medium, definitely it is coming from another medium, right? But what if it is coming from vacuum? Now we know what vacuum is, right? Vacuum is, that means there is nothing, no air, no water, nothing is there, like space. Okay. So when light ray is entering into a medium from vacuum, then the refractive index that we get, it is called the absolute refractive index of that medium. Okay. Now, as it is coming from vacuum, we know that vacuum is empty. You know what vacuum is, right? It is empty. There is no air, no water, nothing is there. No medium is there. So we cannot write here anything, right? If it was coming from air, we could have written air here. But it is not coming from air, water, or glass, or anything. Okay, it is coming from vacuum, and vacuum is empty. That is why nothing is written before it. Okay, whenever there is nothing written before it, you have to understand that we are talking about absolute refractive index. See, I already showed you this one. This means light ray is coming from A to B. So this is the refractive index of B with respect to A. But here, I did not write any medium before. That means the light ray is coming from vacuum. So whenever light ray is coming from vacuum, the refractive index that we will get, it is named as absolute refractive index. So if no medium is written before eta, then you have to understand we are talking about absolute refractive index of the medium that is written after eta, okay, or written as subscript. Okay. Clear? Any doubt?
No, sir. Yes, okay, sir.
So this is absolute refractive index. Now the thing is, air is almost considered as a vacuum. Why? Because when the light ray enters from vacuum to a certain medium, we get a certain value for refractive index. Let us say for a particular medium, it is 1.5. Okay. Then we repeat the experiment by letting the light ray go from air to that medium. Previously, we did it from vacuum to that medium, we got 1.5. And if I do the experiment from air to that medium, we almost get the same value. That is why, when light ray is entering from air to a certain medium, it is almost considered as the absolute refractive index itself. It is written in your book, and you go through the explanation. Okay. So here, my point that I'm trying to state is, if the light ray is going from air, then we will consider it as almost absolute refractive index. Okay, and we will use it in the numerical problems. No need to worry. Inshallah, I will show you the application of it. Okay. Okay, refractive index for. Acha. Now we will try to learn some equations that are needed for mathematical problems. Okay. So let us say, when light ray is going from A to B, you know the refractive index of it. But in the question you have been asked, find out, okay, what is it actually? Refractive index of B with respect to A. Okay, I will write it out for you. Refractive index of B with respect to A, right? This is what is given. But you have been asked to find refractive index of A with respect to B. You have been asked to find out this one. So if I write it in a symbol like this, what will be that symbol? Definitely refractive index of A. That means A will be later and it is coming from B. So B will be first, right? You have been asked to find out this one. How can you find it out? They are just opposite to each other. Okay, they are just reciprocal of each other. That means it will be equal to 1 by A eta B. Okay, so if you know this value, then you can find the reverse of it. Okay, understood? If I give you this value, then you can easily calculate this one also.
Sir, you can explain this again. I have some doubt.
Yeah, okay, no problem. Here light is going from A to B, and the value is given, let us say, as 1.5. Okay, refractive index of B with respect to A. This is given. And then the question says, find out the refractive index of A. Refractive index of A with respect to B. With respect to B. So how can you find it out? The formula to find it out is equal to 1 by what is given. ওকে, যদি উল্টাটা বের করতে হয় we need to just reciprocate it. যেমন মনে করো যদি তোমার g eta w এটা দেয়া থাকে, ওকে, মনে করো 1.33, তোমাকে বের করতে বলছে কি w eta g, তাহলে কিভাবে বের করবা? এটা যেহেতু রিভার্স হয়ে গেছে, এটাকে রেসিপ্রোকাল করে দিব আমরা 1 by 1.33, ফিনিশ, আমার आंसर হয়ে গেছে। বুঝতে পারছো?
Yes sir.
ওকে।
Sir, time finish.
Okay, I will just write the equation. আচ্ছা, equationটা লিখলে আবার explain করতে হবে। Okay, no problem. Inshallah, next day we will explain the equation and kindly go through the mathematical problem that is there in your textbook. Okay, I wrote some equation, right? So kindly go through those equation and solve the related mathematical problems. Okay, see you in the next class, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. And if anybody needs the video, then let me know later.